Hello everyone! Today we will conduct an experiment that anyone can repeat in their home. We will make a universal pH indicator from a red cabbage. First, we will need to buy the red cabbage. Then we need to cut it into about 4 parts. And for the experiment, 1/4 should be enough. Afterwards, further chop the quarter piece into small pieces. The smaller the pieces, the better. You can also crush it using a blender. To make the actual indicator, we need to extract purple pigment from the leaves. To do so, put the sliced cabbage in any container and fill it with boiling water. Then wait for about 20 minutes until most of the water-soluble substances appear in the solution. Now I will explain why do we do it. Red cabbage, as well as many other vegetables, contains natural dyes, i.e. anthocyanins, which gives the fruits and leaves their different colors. The color of these substances will depend on the acidity of their environment. When the acidity changes, the color changes as well. For example, the color of ripe fruit often changes from green to red and from yellow to red. Once the cabbage is settled in the water for approximately 20 minutes, the resulting liquid then should be filtered. And here we have made our universal indicator. In order to show its effect, I'll dilute it in water several times for the solution to not be so saturated. Now I'll pour this indicator into 7 different beakers to show you what colors the substance contained in a red cabbage can acquire. I'll pour sulfuric acid, a very strong acid, into the first beaker, and the solution immediately becomes red, while the acidity of pH is equal to 1. I'll add acetic acid to the second beaker. It is not as strong as sulfuric acid, and the solution becomes bright pink. And I'll add sparkling water into the third beaker. Soda contains carbonic acid that turns the solution in a light pink color, which pH being approximately 4. I do nothing with the next beaker, as there is more or less neutral solution in it. Then, in the following beaker, I'll add the baking soda solution. The solution turns blue, and the pH is approximately 8 or 9, now depending on the concentration. In the next beaker, I'll add the ammonia solution. The solution there turns green, and the pH is now equal to about 12 or 13. Finally, in the next last beaker, I'll add a strong base, sodium hydroxide. The solution turns green at first and then yellow. Yellow indicates pH of about 14. Well, and we have got a diverse palette from one of the colors. But that's not all. It's still possible to play around for a long time with this indicator. You can, for example, make an alkaline solution of yellow color and add an acid to it, such as sulfuric acid, and then you can gradually wash out the transitional colors. Or, conversely, it can be acidic solution, and then adding a solution of alkali or soda to it. You can also do a multi-layer liquid by pouring the solutions very carefully. I would also want to warn you to be careful when you play about with a variety of substances, as, for example, sodium hydroxide and sulfuric acid. If they get on your skin, it will be quite painful, so be careful with it. Anthocyanins are the substances that change color and are contained in virtually any brightly colored fruit plants. As well as indicator, you can also use beetroot, blackcurrant or carrot juice. Thus, the diversity is quite large.